In this video, I'll talk about two-point perspective grids, and it's in my book, Ellen's Guide to Drawing Shapes on Amazon. I'm going to show you two methods for building boxes in two-point perspective. This is the inside-out method, where we start with a box and lengthen all of its sides. Then we use a diagonal that goes from this lower corner through the middle of the side to find the top of the next box and over here. Then establish a vertical measuring line so that lines go to one vanishing point and other lines go to the other vanishing point. And then have lines going from the left to the right vanishing point and from the right to the left vanishing point. This is the second approach toward building boxes, and it's the outside-in method. So we'll start again with the box, but only to set up the grid here. And we need 3 measuring lines with equal units, and we connect units together. And then we use diagonals, so we can start at this point here, go through the top of the box, and where it hits this magenta line would be the position of this vertical blue line. And you continue to do that, and you can see that the spaces get smaller with distance. This gets very complicated very quickly. And so you should probably just pick out the boxes that you need. In this next outside-in method, I first establish the structure. And it's more interesting to have unequal sides, as I show you here. So this one is much closer to its vanishing point and shorter than this one. I set up a horizontal measuring line on the ground. Really, any horizontal or vertical line parallel to the picture plane and touching the ground line can be a measuring line with true values, not foreshortened values. Then draw lines converging toward the center of vision. And where these white lines cross this yellow bottom line would be the position of these green vertical lines. Now, to get these horizontal lines, there are 2 methods. One is, as I show you down here, to set up another measuring line with units that are equal to those on this bottom measuring line, and then just draw the converging lines from each unit. Alternatively, to set up equal units, you can use this diagonal, and where the diagonal crosses the green lines at these pink dots would be the position of the horizontal converging blue lines. And I call them horizontal converging, even though they look like they're slanting, because they go to a vanishing point on eye level, so they must be parallel to the ground. Now, if you want to set up unequal sides like these rectangles, you'll have to set up another measuring line here with the units that you want to use. So you can see that these are rectangles and these over here are squares. Where should we put eye level? Let's assume that the viewer is standing. So for a 1-story building, eye level would be about 60 to 70% up the building because walls are about 96 inches tall and a standing adult is about 60 to 70 inches tall. For a 2-story building, eye level is 60 to 70% up the wall for the first floor. We can consider this the line between the 2 floors. And notice that the top is more angular because eye level is lower. This is what a viewer would see looking at the building from across the street. Now, if the viewer were standing on the 2nd floor of a building across the street, this would be the eye level because it's 60 to 70% of the top story. And notice this time that this part of the building is more angular because the eye level is high. Once you have a grid with squares, true squares, then you can put things to scale. So this door, for example, is 2 blocks wide and 5 blocks tall. And this door, too, is 2 blocks wide and 5 blocks tall. This method is useful when you have unequal units. So I drew a black box in 1-point perspective, and I'm trying to find this yellow box. We can't use multiplying rectangles because the space for the box is larger than the space in between the boxes. So instead, we have to use these diagonal vanishing points. So you draw a diagonal from up there to down here to find the diagonal vanishing point, which is vertically below the box vanishing point. Then, at the red dot, draw another diagonal down to the diagonal vanishing point. And where that diagonal crosses this lower line would be the furthest extent of the yellow box. And we could also use these diagonals, which go to a vanishing point above the box vanishing point. To create equal boxes in two-point perspective, establish a diagonal vanishing point that is as far from the vanishing point as is the eye. So you could draw a circle with the vanishing point in the center that hits the eye and hits this diagonal vanishing point. You could also do it the other way, a circle like this. So a diagonal vanishing point would be over here using VP2 as the center of the circle. So again, we start, for example, at the bottom of this box and find where the diagonal hits the top of the box. And that would be point 2 for this next box that we're trying to find. To draw a box that's 3 by 3 units, start with a measuring line with equal units and draw lines to one vanishing point over here and to the other vanishing point over here. And where they cross the base of the box would be the position of the vertical lines. To find these horizontal converging lines, you can either use 3 vertical measuring lines, 1, 2, 3, or you can use the diagonal. Even the diagonal on top works, although it's pretty crowded, so it's hard to see. Then it depends on what you want to do. You could isolate some boxes in the structure, or you could draw a curve and mirror it in back and then connect like parts together. You use a grid to find the different points. This XYZ space is used for complex, usually symmetrical objects like cars and planes. In my next video, I'll discuss inclined planes and other uses of more than one vanishing point. And please remember to subscribe.